have the Eagle One drone, and we start out with the drone itself and its movement of how it flies and everything. So we have thrust, pitch, roll, and yaw. What thrust is forward and backward movement. Pitch is basically the nose dive and up. Roll is the wings moving from side to side, the wing flaps, and then the yaw would be the nose itself going from side to side. We can start the simulation, and right off the bat, once the thrust is activated, as you can see, the motors start moving. If there is no thrust, no forward and up movement, basically, then they stop moving. Here we go, let's set it right here, and then once the pitch, which would be the up movement, these also change, as you can see. And then we set it down to nothing. For the roll, this is the numbers start to change, and for the yaw, and this would be the code for it. This is the back forward movement, this is the right movement, this is the rotation, and all the input values. They all start at idle, and then these are all the pins that it is connected to. Then they will start out in high. Once it is pressed up, then it will go back and forward, depending on whether it's higher than 5 or lower than 5. And then similar situation for left and right for both pitch, yaw, for the pitch, roll, and the yaw. For the second part of the Eagle drone, we have the heat sensor. And for the heat sensor, basically how it works is this is the code, this is the things for the display, and it will start up. And for this temperature sensor, it goes only as far as 256.65 degrees Fahrenheit, unfortunately. So it cannot simulate the 1200 Fahrenheit that we're looking to do with our robot. That would take a maximizers and another thermal sensor that Tinkercad does not have. So this is as much as I can read with this, unfortunately, but the simulation is still basically the same. As I move the cursor up or down, it tells me the temperature, as it would for the drum. It converts the voltage into the temperature, and then from Celsius, it converts it to Fahrenheit, and it displays it on screen. And then finally, we have our third part of our drone, which is the system offline feature. This knob right here basically simulates what would happen whenever the system goes offline. So we start the simulation right here, and as we can see, when it is online, nothing happens, and this buzzer right here, this one, the piezo, will stay quiet, as well as the LED stays turned down. But once it turns on, then this will indicate to the response team that it has been disrupted, like this. When it is turned all the way down, it means that the system has gone offline. Give me 1 second. And basically, I will start the simulation. If I start it right here, as you can see, it is normal, but then when I turn it down, it says that the system has gone offline, and it is a drone alert. Once it goes back to normal, then the system stops ringing, and this is the code in itself. Thank you.